Okay, this is section 8.5, drawing Lewis structures. Drawing Lewis structures is one of the most important things that we learn in general chemistry because Lewis structures are used in subsequent courses and they serve as a method of analyzing chemical reactivity. So what I'm going to do is I'm going to show you a few molecules and I'm going to step you through the step-by-step process of drawing their Lewis structures. So I'm going to start with a simple one, which is methane, CH4. The first step is to identify which of the atoms is called the central atom. And the way you determine that for simple molecules like methane is one of the atoms, one of the elements, will only have one atom. So if you look at CH4, there's only one carbon, but there are 4 hydrogens. So we identify the element that has one atom as the central atom. So that would be carbon. The other ones, the ones that have more than one atom, those are called surrounding atoms. So hydrogen would be the surrounding atom. Okay? So then we draw what's called the skeleton. Okay, so you draw the central atom at the center, and you connect each of the surrounding atoms to the central atom with one covalent bond. And remember, a bond has 2 electrons. Right? That's the notation we use. The straight line between 2 atoms has 2 electrons. Next, we count up the valence electrons. Okay? The way you do that is you go to the periodic table and you look at each element. Carbon is in column 4A, so it has 4 valence electrons. Hydrogen is in column 1A, so it has 1 valence electron. But there are 4 hydrogens, so we multiply that by 4. So it's the number of valence electrons times the number of atoms of that element. And then we add them together. 4 plus 1 times 4 is 8. So that tells us there are 8 valence electrons. We then subtract the electrons that we've already drawn in with the lines, right? Each bond is 2 electrons. So here's 2, here's another 2, here's another 2, and there's another 2. So we subtract that. These are the electrons used. And we're left with 0. Okay? So now what we do is we test the octet rule. Elements in the second row should have 8 valence electrons in their Lewis structures. So if you count up around carbon, there's 2, there's another 2, there's another 2, and there's another 2. That's 8 electrons. So this would be our Lewis structure. So we would say that the methane molecule has 4 single bonds, 1 to each hydrogen atom. Okay? Let's try it for another one. I'm just going to show you a few of them, and then you can, of course, practice as many of these as you want. The second one I'm going to show you is carbon tetrachloride. This one's a little more complicated, but not much more. Okay? So first thing, we identify the central atom, carbon. There's only one carbon, but there's 4 chlorines, so carbon would be the central atom. We connect it with 1 bond. Each bond is 2 electrons. And we're not going to use dots to represent these bonds. We're going to use lines. Okay? Surrounding atoms are chlorine. The next thing we do is we count up valence electrons. So carbon is in column 4A, so it has 4 valence electrons. Chlorine is in column 7A, so it has 7 valence electrons. We add them up. There's 1 carbon and 4 chlorines. That gives us 32 electrons. Now, so far we've used 8. So I'm going to subtract 8, right? Each of those bonds, we've already put in a bond to each of those chlorines, so we've already used 8 electrons. Now the question is, how do we distribute the 24 electrons? The first step is to distribute them evenly, meaning the same number around each surrounding atom. And again, we're looking for the octet. 8 electrons on each atom. So do the surrounding atoms first and distribute them as pairs. So I put 6 there. Now that chlorine on the right has 8 electrons, 2 in the form of a bond and 6 in the form of lone pairs. 3 lone pairs, but 6 electrons in those lone pairs. Do the next one. And you just keep putting electrons on each surrounding atom until the surrounding atoms are completed or you run out of electrons. So look what happened. Every time I put 6, I would lose 6 from our 24. So 24 minus 6, minus 6, minus 6, minus 6, right? 4 chlorine atoms. We're out of electrons. We then check to make sure that each atom, unless it's hydrogen, has 8 electrons. And your counting is done in the following way. A bond counts toward both atoms. Lone pairs only count for the atom that they're connected to. So this chlorine now has a total of 8. Octet. This chlorine now has a total of 8. This chlorine now has a total of 8. And this chlorine now has a total of 8. Okay? What about the carbon? The carbon has a total of 8. There are 8 either shared or lone pair electrons for each of those atoms. That's the octet rule. Okay? So let's try another one. We're essentially going from simpler to more complicated ones here. The next one is water. Water is actually a pretty simple one. So there's only one oxygen, but there's 2 hydrogens. So we draw the oxygen in the center, surrounded by 2 hydrogens. We then say, how many valence electrons are there? Well, oxygen is in column 6A, which means it has 6. Hydrogen is in column 1A, which means it has 1. So the total number of electrons would be 6 for the oxygen. There's only one oxygen, so I'll write 1 times 6. 1 for each hydrogen, but there's 2 hydrogens. Oops, 2 times 1. And you get 8. 8 valence electrons. We've already used 4. Right? Each of those bonds is 2 electrons. So now we're down to 4. Now, before, in the previous example, we distributed them as lone pairs around the chlorine, the surrounding atom. But in this case, it's hydrogen is the surrounding atom. And hydrogen can have a maximum of 2 electrons. So we're not going to add any to the hydrogen. If we can't add them to the hydrogen, we add them to the central atom, oxygen, in the form of lone pairs. So now oxygen has 8 electrons. Hydrogen has 2. We're set. Okay? That's water. Water is a relatively simple one. Let's try the next one, which is oxygen. In this case, there's only 2 atoms, so we don't have to worry about which one is the central atom. So now we count up valence electrons. Oxygen is in column 6A, so that means it has 6 valence electrons. There are 2 of them, so that's 12 valence electrons. We've used 2. That gets us down to 10. Now we have a choice. How do we do this? We could put 5 of the electrons on each oxygen, or 6 on one and 4 on the other. So I'm going to do that, actually. What I'm going to do is say this. Put 6 3 lone pairs on one of them to get it up to 8. Now that oxygen has 8. And then do 4 on the next one, instead of doing 5 on each. Okay? So now we've subtracted 10, we're down to 0. The only issue here is that the oxygen on the right is deficient. It only has 6 electrons. That's no good. Remember, we want the octet. The octet is what we're looking for, 8 electrons. So here's the trick. What you do is you take the atom that has 8, this oxygen has 8, and you push a pair of electrons that's in the form of a lone pair into a form of a second bond. And I'm going to show you the notation for doing that. You use a little arrow. The arrow is representing where you're moving those electrons to, the curved arrow. And then below, I put a double-headed arrow to indicate that we're drawing a different Lewis structure based on the previous one. Once we do that, now we find that 2 pairs of electrons are shared between each oxygen atom. And they now both have 8, right? Because remember, all 4 electrons in the double bond count for each atom. So that's 4. Each atom has 2 lone pairs, and there you go. So get one of the atoms up to 8, and then push a pair over to the other atom that doesn't have enough so that they both have 8 electrons. Okay? Let's try one more. These are for the simple ones. We'll look at more complicated ones later in the chapter. So the next one is an ion. Cyanide, Cn-. Okay? This is called the cyanide ion. The cyanide ion is pretty cool, but it has a negative charge. So here's what we're going to do. We're going to follow the same format. A single bond. Now there's only 2 atoms, so don't worry about a central. We just need to take into account the extra electron. Carbon is in group 4A, so it has 4 electrons. Nitrogen is in group 5A, so it has 5 electrons. And then we got that negative charge, so that's 1 electron. That's an extra electron. 1 additional valence electron. If it were positive, you would take away 1 of the electrons. But if it's negative, you add it. If it was -2, you would add 2 electrons. If it was -3, you would add 3 electrons. Okay? So now we get 10 electrons. We've already used 2, so we're down to 8. So again, pick one of the atoms and get it up to 8. So I'm going to do the carbon by adding 6, and then I'm going to add another 2 to the other. It doesn't really matter which one we do in this case. I could have put 6 on the carbon and 2 on the nitrogen, or vice versa. It doesn't really matter. You'll get the same answer for this one. Okay, so now the carbon has 8, but the nitrogen only has 4. Remember, 4 electrons, no. 6 electrons, no. We don't want that. We want 8 electrons. Yes. So the nitrogen only has 4. 2 in the form of a bond and 2 in the form of a lone pair. So we do the same thing. We push a pair of electrons. That will get the nitrogen up to 6 because it now gets to count them as a bond. Push another pair, and that gets it up to 8. So now I'm going to draw the double arrow. I've pushed 2 pairs, so now I just have 1 lone pair on the carbon. We now have 3 bonds to the nitrogen and 1 lone pair. If it's a charged species, we put brackets around it and write the charge outside the brackets to indicate that that ion is charged. Okay? So those are steps for drawing Lewis structures. It's all, I've just repeated what's in your textbook under section 8.5. We did cyanide, we did oxygen, we did water, we did carbon tetrachloride, and we did methane very formulaically. Practice the problems.